Welcome to Section 8.3 Part 2 video. If you watched Part 1 video, wanted to point out real quick a common mistake here on number 8, which is that some people will attempt a FOIL problem there because they're seeing 4 things and they think, oh yeah, FOIL, 4 letters, but there are no pluses and minuses. So where we left off here for Part 2 video are FOIL problems. So hopefully you'll notice there are 4 parts, but there is, in fact, a plus in between them. So it does make them a pair of binomials. So off we go. I'm going to do a box on this one. So box users, feel free. If you don't want to use the box, don't use the box. Doesn't matter. I think this is actually pretty helpful for these. So first times first, which would be those corner boxes, gives me a 6. 2 times the square root of 5. Well, 2's on the outside. 5's on the inside. I cannot put those together, but I can do that. Square root of 5 times 3. Similar idea. The last one times the last one. Now you can shortcut this, but I'm going to be careful here. So the fact that I'm multiplying a 5, which is inside, another 5, which is inside, should give me an answer that's inside. Add the stuff up in the box. All right, well, I am going to write this off to the side. You're welcome to do it this way if you want. Can't leave the square root of 25. No, I'm always supposed to simplify, and that's 5. So now I can add those 2 corner boxes. I get a 6, I get a 5 for a total of 11. And this is getting ahead of ourselves a little bit, but I'm hoping this is going to make sense to you. So we can only add like terms. Here's 3 of something and 2 of something, and the somethings are the same. So 3 apples and 2 apples would be 5 apples. 3 x's and 2 x's would be 5 x's. So 3 of something and 2 of something would be, have no idea why I wrote a 3 there, would be 5 of the same something. So 3 square roots of 5s and 2 square roots of 5s makes a total of 5 square root of 5s. So I hope that makes sense to you. Alrighty, can I add the 11 and the 5 square root of 5? Well, no, because the 11 is a regular old number and 5 square root of 5 obviously is not. So number 11, if you noticed that it's a conjugate, that means you wouldn't have to do the whole FOIL process, and I'm going to do that. So I'm going to shortcut. So if I know it's a conjugate, conjugates only have to be first times first. Got it. And the last one times the last one. Okay, again, feel free to shortcut that. You will not offend me if you do. So if you were thinking ahead that I'm going to get the square root of 9, and the square root of 9 is 3, that's fine. So where did the square roots go? Well, in that particular problem, they disappeared. And remember, that was kind of the point of a conjugate. So conjugates got rid of i's, got rid of square roots, got rid of all those funky parts of the problem. Regular old whole number left. So that's it for that guy. Number 12. A little tougher FOIL problem. Again, box it if you want. I'm not going to bother this time. First one times first one. Outside 2. Well, 1 times anything is itself. Inside 2. Okay, now here's my only advice to you. If multiply is multiply. So the fact that I'm multiplying this, which has a 2 on the outside, and a 2 which is on the outside, I can multiply the outside guys together, but I'm stuck with a 6. Last one times last one. Now again, first of all, let's do this. Negative times a negative is a positive. I have a 2 on the outside, but I don't have any other outside numbers. I have a 6 and a 2, which are both on the inside. But times is times, so I can multiply those together, and I got the square root of 12. So the only question is, can I simplify anything? Can I do anything? Well, just like regular old common terms, you can only add x's and x's, y's and y's, etc. I can only add square root of 2's to other square root of 2's. I don't have any more. I can only add square root of 6's to other square root of 6's. I don't have any more. That is a 2, not a z. And obviously the square root of 12 is different as well. However, there is a reason we taught you factor trees. If you can do a factor tree that is helpful, you need to do it. So back to that last one, the square root of 6. Could have done a factor tree for it, but it gets me nowhere. But on this one, well, what's the square root of 4? Square root of 4 is 2. So I already had a 2 out in front. Now I got another 2, and I get that square root of 3 left over. So clean it up one more time. regular number, square root of 2. No more square root of 2's. 4 square root of 6. No other square root of 6's. Clean this guy up. I got 4 square root of 3. So I can't combine any of those because they are all unlike terms. And that guy's done. All right, 13. You guys are killing me with this. What's it mean to square something? It means to take that thing, which in this case is 9 plus the square root of 7, and multiply it by itself. So if I write it out twice, does it now look like a FOIL problem? Yes. Please, I'm begging you. First time's first. Outside 2. Inside 2. Last one times last one. And again, if you want a shortcut right there, you are welcome to do so. You're probably thinking to yourself, hey, I knew that was going to be the square root of 49, but I'm going to go ahead and write it. Clean it up. Like terms, 9 of something and 9 of something would be 18 of the same something. So you probably could have skipped this step if you already knew or had written down 7. But now that I wrote down a regular old 7, I can combine it with that 81, total of 88. And finally, I got my last answer. So I don't think the FOIL problems are too bad. All right, I'm going to go ahead and real quickly here show you the idea with the add subtract problems, and you can pick it up with video 3 from there. So take a look here in the box. We just talked about this. These guys are like terms. I'm allowed to add them together. These guys are not. I can't add them together. So the fact that I have a square root of 11 and a square root of 13 means I cannot combine them. So this would be over here, this guy would be similar to having like an x to the third and x to the fourth. Can't combine those either. So they have to be like terms literally. They have to be the same. So if you look at 14, well, they are the same. So 5 of something plus 7 of the same something minus 1, minus 1 of something. So I just have to add up the coefficients like you would in a normal problem. So 5 and 7 is 12. 12 minus 1 is 11. But just like up here, you would write 5x. You wouldn't change the x part. So same thing down here. I'm not going to change the square root of 14 part. So 5 of something plus 7 of something minus 1 of something would be 11 of the same something. All right. So for 15, parts of these are equivalent or like terms. So it's like adding up a bunch of x's and adding separately a bunch of y's. I can't add the x's and the y's together, but I can at least add this guy to this guy. So 1 of these plus 7 of those would give me 8 of the same thing. 6 square root of 2 minus 8 square root of 2. So it's like 6x, or right above, it's like a 6x and a minus 8x. So if they're like terms, yeah, we would always take care of the coefficients. So 6 minus 8 is 2. But instead of writing x, I'm just talking about square root of 2's this time. So the part that follows the coefficient stays the same. Okay, so a quick preview on that. I'm running a little low on time for the video, so I'll just go down here and I will show you that these next examples coming up, these are not common root numbers. And if they're not common root numbers, guess what? You got to do factor trees. A little tedious, but come on, factor trees are not particularly difficult. All right, so not enough time to finish these up for part 2 video, so feel free to check out part 3 video if you'd like to see how to deal with the ones that are not common square roots to start with. Thanks for watching.